Okay, so is the recording started? Okay, so in this video we will see the next 5 questions for the GCP PDE exam from question number 46 to question number 50. So let's start. So question number 46, you work for an economic consulting firm that helps companies identify economic trends as they happen. Okay, so we are working for some consulting firm which will help to to identify some trends for the other companies. So as part of your analysis, you use Google BigQuery because we want to identify some trends. So basically to do some analysis, for the analysis purpose we will use Google BigQuery. Okay, fine. To correlate customer data, fine, and the average with the average prices. Okay, fine. The average prices of these goods are updated with 30 minutes. Okay, you want to make sure that this data stays up to date so that you can combine it with other data in BigQuery as cheaply as possible. Okay, so what are the keywords? So the keywords are like we want to do some analysis and the data is in the BigQuery and the data is getting changed after every 30 minutes, right? And so you want to make sure that the data stay up to date so that you can combine it with the other data in the BigQuery. So let's suppose we have some data in the BigQuery and the newly data which just come, it was changed after 30 minutes. So we want to load the data into that BigQuery, or you can say that the new trend, new analysis should reflect this newly reflected data, and we need to design a solution cheaply as possible. So this is also the keyword, cheaply as possible. Okay, first thing is that load the data every 30 minutes into a new partition table in the BigQuery. So this is wrong. Why this is wrong? Because they told that okay, whenever there is a new data in 30 minutes, load that into the BigQuery. Loading that data into BigQuery is okay, but why we like to load a data into the new partition table? So does it mean after every 30 minutes we will create a new partition table? No, which is wrong. Why it is wrong? First thing is that the cost is very high, and second thing is when we have to do some analysis on the new data and the existing data, so how many tables we will take consider as part of the query. So option A is wrong. Second thing is store and update the data into the regional Google Cloud storage bucket and create a federated data source in the BigQuery. Okay, so this looks okay, because so what it is saying that do one thing, whatever the latest data, so store the data into the Google Cloud storage bucket. But if the data is getting stored into the Google Cloud storage bucket, how we will run the query into the BigQuery? So create a federated source, data source in the BigQuery. So in the BigQuery, when we run select star from BigQuery table, right? So there are one more queries available. We can get the data from any another source. So that is create a federated data source in BigQuery. So that looks perfectly okay, and we are storing the data into the regional cloud storage bucket. So it is not the multi-regional, it is the regional. So if we store the data into the regional, so it is cheap as possible, and second thing is that it will be the latest, and there is no need to load the data into the BigQuery. So we can directly run the SQL on the Google Cloud on the data which is stored into the Google Cloud storage bucket. So if you see the official documentation, so in the official documentation Introduction to the external data source. External data source is data source that you can query directly from the BigQuery. So let's suppose we have the data into the BigQuery and some data stored in some another source. So there is no need to like load the data from another source into the BigQuery. We can directly like run simple SQL commands to get the data, to read the data from the another sources. Right, so the another source could be Cloud SQL, Cloud Storage, Drive, Bigtable, right? And so federated queries is a way to send a query statement to an external database. So we will like send a query statement to the external database, that is the cloud storage in this case, and get the result back to the temporary table. Okay, so that will be the easy. But let's look at the other option. Store the data into the Google Cloud Data Store. Okay, use Google Cloud Data Flow to query BigQuery and then combine the data property with the data stored in the Cloud Data Store. But like this is not a like cheapest process. They told that okay, do one thing, store the data into the Cloud Data Store and then create some pipeline, then read the data from the BigQuery and read the data from the Cloud Data Store and combine them. So this is not a cheapest, but even it is still more like overhead. Fourth is store the data into the regional cloud storage bucket. Okay, fine. Then use Cloud Data Flow query to BigQuery and combine the data with the. This will also work, but this is not the cheapest. They told that okay, we will store the data into the Google Cloud Storage bucket, and then from the Google Cloud Storage bucket, we will load the data into the BigQuery. And once the data will get loaded into the BigQuery, we will like do some trend analysis on the available data into the available data into the BigQuery. But why we need to load the data into the BigQuery when we can like directly run a query like on a external data source, or you can say the federated data source. So B like looks more relevant out of the 4 option. So if we reveal the solution, they said C is not the correct answer. So if you go to the discussion tab, so most of the people say B. So we will go with the B. Okay, so let's see the question number 47. So question number 47 says that you are designing the database schema for machine learning model. Machine learning based food ordering service that will predict what user want to eat. Okay, here is some of the information: the user profile, user account information, the order information. The database will be used to store all the transaction data of the product. You want to optimize the data schema. Okay, so which database we will use? So first thing is that we want to design the database schema and we want to optimize the data schema, right? So we need to like, you can say you can change the schema or optimize the schema, and we need to do some machine learning algorithm as well, and we want to store the transaction data as well, right? So if we consider the Bigtable is the NoSQL database, right? So we can't like design the schema, so the schema will be same, right? So we will not consider the Bigtable. Similarly, the Cloud Data Store is also the NoSQL, so we will not consider this. So one thing is that the BigQuery is like you can say the SQL, and Cloud SQL is the also SQL. But out of these two, like I will prefer to go with the BigQuery because like we have to perform the machine learning algorithm as well. So in the BigQuery we can directly perform the machine learning algorithm from the data which is stored in the BigQuery, so rather than like first storing the data into the Cloud SQL and then reading the data from the Cloud SQL and then perform the machine learning algorithm. So we can directly perform the machine learning algorithm. So I will go with the A, that is the BigQuery. But if we go to the discussion tab, so some people say A, some people say A, right? Some people say B, some people say D. So like they are also not sure like what could be the correct answer, but like as per me it could be the A. Okay, question number 48. Your company is loading CSV file into the Google BigQuery. Okay, fine, we can load the CSV file into the Google BigQuery. The data is fully imported successfully, fine. However, the imported data is not matching byte to byte to the source file. So what could be the problem? So what question say that we have one CSV file, we load the data into the Google BigQuery and all the data get loaded successfully, but when we have compared with the source, we found some mismatch, right? So it is not like matching byte to byte. So what could be the problem? So the CSV data loaded in the BigQuery is not flagged as CSV, wrong. We already said that it is a CSV. The CSV data has invalid rows that were skipped on import, wrong. We already mentioned that we have imported all the data. So all data, fully data is successfully. So there is no concept of the skipped. Third option is the CSV data loaded in BigQuery is not using BigQuery default encoding. So that is correct. So because of encoding, like we are facing this issue. Fourth is CSV data has not gone through the ETL phase before loading into BigQuery, wrong. To load the CSV data into the Google BigQuery, we can directly load the CSV data. There is no need for the ETL process. So the correct option is C, that is the CSV data loaded into the BigQuery is not using BigQuery default encoding, because the BigQuery only use the UTF-8 encoding scheme. So if the CSV contains like any other format, so the data will be loaded successfully, but it will not match byte to byte. So if we go to the official documentation and details of loading CSV data, so if we read the official documentation of the Google Cloud, we can see the BigQuery expects CSV data to be the UTF-8 encoded. If you have CSV file that were encoded to some another scheme, so we can either convert to the UTF-8, or if we have not specified the encoding scheme, then BigQuery attempt to convert the data to UTF-8. Generally your data will be loaded successfully, but it will not match byte to byte what you expect, right? So to use this, we need to specify the encoding flag. So this is the reason, because BigQuery like expect the data into the UTF-8. So one of the they told that okay, what could be the problem? So encoding is the problem, because the data is imported successfully. So skipping is not the concern, CSV is not the concern, ETL is not the concern. So the rest is the encoding. So we reveal the answer, it is C. If we go to the discussion tab, so all the people say like it's C. Okay, let's go to the question number 49. Okay, so question number 49 says that your company produce 20,000 files every hour. Fine. Each data file is formatted as a CSV. So we are producing a 20,000 CSV files, and all the files are less than 4 KB. Okay, all files must be ingested into the GCP. So it means like we have to ingest the file into the GCP. So it means like we are either like generating these files in our own premises databases or on premise system, or on sub website, right? Your company site has 200 millisecond latency to Google Cloud. Okay, millisecond latency. Okay, and your bandwidth connection is limited to 50 Mbps. Okay, and you are currently using the FTP server to server on a virtual machine GCP engine as an ingestion data point. Okay, the local SFTP client runs on a dedicated machine that transmits the CSV file. Okay, the goal is to make a report that the data will be previously day available to execute by 10 AM. Okay, this design is barely able to keep up the current volume even though bandwidth utilization is rather low. Okay, they are told that due to seasonality, your company expects the number of files to be doubled in the next 3 months. Okay, so what action should you take? Okay, so it's a long question. So what actually it is saying that our company is generating CSV file, and 20,000 CSV file we are generating, and we are generating in some like on premises. So it is not in the Google Cloud platform, but we have to send the data into the GCP. So how we will sending the data? We are sending via some internet, right? And the internet speed is very low, that is a 50 Mbps, that is limited. Bandwidth is very limited, so it is mentioned bandwidth is very limited, and we are using the FTP protocol, that is okay. And we need to make sure that the file will be available by 10 AM each day, but due to like low speed, so this is not like happening. And even like it is mentioned that because of some season, like we are expecting a double volume of the file. So now it is like 20,000 files every hour, so it could be like 40,000 files every hour. So even if we have the 40,000 files every hour, already 20,000 files we are not like sending within time. So how we will send the 40,000 files? So what approach we should follow so that we can send the 40,000 files or even more within a time? So let's try to first eliminate the option. So first option is introduce data compression for each file to increase the rate file of file transfer. Increase the rate file of file transfer. So that looks okay, because if we compress the file, then the file transfer will be will increase. So that looks okay. Second is contract your ISP to increase your maximum bandwidth to 100 Mbps from 50 Mbps to 100 Mbps. So this is wrong, because the concern is not here to increase the speed. So we can increase the speed, definitely we can increase the speed, but here question is, if we have the limited bandwidth, what solution we can suggest? This is not the solution to increase the speed, so we will not select the B. So B is eliminated. So and in the question we have mentioned that we have to choose two options. So now we out of 5 we have A, C, D, E and left. Okay, second option is redesign the data ingestion process to use GSUtil tool to send the CSV file to storage bucket in parallel. Okay, now we are sending from using FTP protocol. So they told that redesign the ingestion process and use the GSUtil. So that's look okay, because if we use the GSUtil command, then we can send the files in the parallel and the speed will also get increased. So C also look okay. So till now A and C looks okay, but let's read the D and D. Assemble 1000 file into a tar file and transmit the tar file. Okay, so that looks also okay to me, and because they told that do one thing, we have so many files, so we will make a zip of 1000 file and then transmit the zip and then unzip the CSV on the cloud. So in this way we will transmit 1000 file in a single go. Okay, now option E, create the S3 compatible storage endpoint for your network and use Google Cloud Transfer Service to transfer the file. So they told that do one thing, rather than the FTP protocol, use the Google Cloud Transfer Service to transfer the files, but Google Cloud Transfer Service only be used if our bandwidth is very high. But here we have mentioned the bandwidth is low, so E is also neglected, or you can say reject here. So we have option A, C, D, but we need to select only two options. So A looks okay, C looks okay, D looks okay, but I will not going to select with the D. I am going to select with the A and C, because they have mentioned assemble 1000 files, right? On what basis they assuming this number 1000? So let's suppose now we have the 1 lakh files. So what will they will do? So still they will zip the file, zip 1000 files in and make a one tar file. No, so they have to make more tar files. So how they are assuming that we need to make a zip of 1000 file? So I do, out of these three, A and C looks really good to me, but not this D. So I am going with the A and C. If we reveal the answer, so answer says C and D, so which looks wrong to me. If we go to the discussion tab, so even in the discussion tab, most of the people say A and C. So A and C, and few people say C and E as well, but I am not going with the C and D. C looks okay, but E is not looks okay. They told that Google Transfer Service. So we have the low bandwidth, so there is no use to use this service. But we have to compress the file so that we can transfer it fast, and also we need to use the GSUtil tool. So A and C looks okay. Now look at the question number 50. Okay, so you are using a NoSQL database. So the keyword is NoSQL database to handle telemetry data submitted from the millions of IoT things. Okay, the volume of data is growing at 100 TB per year. Okay, and the each data entry has about 100 attributes. Okay, the data processing pipeline does not require atomicity, that is the ACID property. Okay, however high availability and low latency are required. Okay, so they told that so these ACID properties are not required. So that is it is you can't consider it is a transaction data. So generally in the transactional data we need the ACID property. So these ACID properties are not required, and we need the NoSQL database, right? And we need the high availability and the low latency. So which database like we will suggest. So you need to analyze the data by querying against individual fields. So which database we will suggest? So first, like, let's try to eliminate the option, because it is mentioned here we need the NoSQL database. So option C is rejected, right? MySQL, because MySQL is the NoSQL, it is not the NoSQL database. So option C is rejected. We need to choose three options. So one option already gone, right? Now we have the 5 option. Okay, so let's look at it. We also like remove the Redis, because Redis is neither the SQL, neither the NoSQL. It is the in-memory database. So we can't store the terabyte of data, even 100 terabyte of data into the Redis, because it is an in-memory database. So Redis is also like we can remove. So now we have the 4 option left, right? Now look at the HDFS with Hive. So in Hive we use the SQL queries, right? So it is not the NoSQL database again. So F option is also like wrong. So what is left? That is the HBOS, that is the Hadoop database. So Hadoop database is the NoSQL database. MongoDB NoSQL database. Cassandra NoSQL database. So B, D, E is the correct answer. But here they have mentioned BDF, but as per me BDE is the correct answer. So if you go to the discussion tab, so most of the people say BDE, BDE, BDE. Okay, so yeah, that's done. So if you think like because all the answer I am providing as per my knowledge only, and as per like by checking the discussion tab and their like comments what they suggested, and then cross verifying over like on few website. But if you think like this should not be the correct answer, so like you can tell me, I will like correct myself as well. Okay, that's the end of the video, so let me stop the recording.